In this video, we're going to talk about how we can do manual summarization on EIGRP. Remember that we have, if we don't disable it, we have auto summarization to the classful boundaries on EIGRP. It will summarize to the major networks. The problem is that typically on a real-world environment, this is not something that we would desire to do because the possibility that we're going to black hole traffic, it's too great. Because remember, just any network that we have is gonna summarize it and send it out saying, yeah, I have the classful, all that classful space in this particular device in this particular area. And unless your addressing scheme is perfectly designed for that, it's 90% of the time it's not going to be that. So we typically do want to have summarization to make routing tables smaller and routers more efficient. There's really no point if we are designing our addressing space correctly, and we have a /16 that we have subnetted into 50 or 100 or any number of different subnets, smaller subnets /24, that we send all that information, and the router ends up with having 100 routes that are pointing basically to the same place. So in those type of scenarios, then yes, we can summarize, and to do that we do it manually. So let's see how we can actually do that on EIGRP. We're going to use this example. We're basically imagining we have some loopbacks, or we have some interfaces on router A that have this addressing. And that's going to, of course, that's going to be sent in updates to router B. And router B is going to follow the normal dual process. He's going to put it on the routing table. He's going to use the formula. In the formula, he's going to add the advertised distance from router A, and he's going to add his cost to reach router A and put the feasible distance in the routing table. Normal EIGRP dual processing there. The routing table is going to look something like this. Of course, these metric values we have pretty much invented, but you get the idea. Like for example, we're going to have that for the .1, we're going to have a metric of 2. The outgoing interface is going to be Ethernet 0, so that means it's going to be Ethernet 0. Then the next hop is router A, so like that. And under normal circumstances, B is going to send that same information to router C, who is going to do the exact same process of seeing the advertised distance from B, adding his cost to reach B, and then making that the feasible distance and choosing the smallest metric if he has multiple paths of reaching that same destination. And we can see here the routing table for router C is the same thing. We're going to have those 3 routes there, and the metric is going to increase accordingly. The outbound interface, which in this case will make that Ethernet 0, and that the next hop is router B, assuming that C doesn't have any other way of reaching those networks. So yeah, everything looks normal and standard there. Now let's say that, of course, here we only have 2 for simplicity and not to have a diagram this big. But imagine that instead of those 2 or 3 networks, we have 50 or 100, like I said before, and they all reside in router A. There's really no need for us to have that many specific routes in the routing table. So let's say we want to summarize that. And let's say that we want to manually summarize that here on B. So C doesn't get that specific information. He just gets a summary update that he's going to use to just anything that matches that, he's going to send it over to router B, and router B in turn will send it to router A, where the network resides. So let's summarize these 2 networks here. We'll leave the all 10s /0/24 as something that we can see later on, also leaving in C. So we choose not to summarize that one, because we could just summarize 10.000/8, and yeah, we'll be done there. So the summary for that is going to be 10.10.0.0/22. We're going to configure that in the interface that's facing router C. So that's going to be configured in this interface here. And when we do that, what's going to happen? A few things are going to happen. What's going to happen first is that we're going to see an entry being put in our routing table, which is going to be that summary. and it's going to use the metric of it's going to use the smallest metric of the routes that summary is actually encompassing. So it's in case it's going to be 1, and the outbound interface is going to be null 0, and also the next hop is going to be null 0, and it's going to have an AD of 5. You can change that, but by default on EIGRP summaries have an administrative distance of 5. And what's the idea of that route being put there? Well, the idea is that it's a protection mechanism against black holing traffic, against resulting in a loop, because we misconfigure this. What happens here? Well, if that doesn't exist, and it gets to C, and we didn't calculate this properly. This gets to C, and we didn't calculate this properly. It's gonna get to B, and since it doesn't have that in place, we have the possibility of black holing traffic, or even if we have more specific routes, sending over to 8 when it doesn't really exist there. So the goal with that in place is going to be to minimize the possibility of loops, and it's going to be that any traffic that reaches B for that particular prefix, of course, should have a more specific entry on the routing table. So B should be able to route anything that comes in, and if it doesn't, that route is going to allow traffic to be dropped right there and not pass on by another summary or another. That's why it also has such a small administrative AD, basically, admin distance. And also what's going to happen is that now those two more specific prefixes are not going to be sent out to C. The only thing that C is going to receive now is going to be this new prefix, and it's going to get C doesn't know that's a summary. For C, it's going to be a normal plain, just another route in EIGRP. He's going to stop receiving the two more specific one, and he's going to receive that new prefix normally. It's only identified as a summary on the router where we're actually doing that configuration. And that summary is going to have the smallest metric of the encompassing routes. So it's going to have, for example, we'll have it here, it's going to get, we're going to delete that. So that's going to disappear, and that's going to disappear. And we're going to have a 10.10.0.0/22 with a metric of 1 plus whatever it's the cost of C to reach B, let's say 1, and a metric of 2, and an outbound interface of Ethernet 0 and next hop of router B. That's basically what's going to happen as we jump into devices and do that particular configuration. So let's go ahead and see that. Let's go ahead and open our topology, and we're here on B. So always a good idea to check that our assumptions are correct, that those loopbacks exist, and we are sending them over. So we can do show IP int brief, and they seem to be there. And if we go to B, do show IP route, they seem to be there with their respective metrics, which they're not going to be as nice as the ones we had in the previous example. Do the same thing, and we can see them there. We can see that both 10.10.1 and 10.10.2, and we can see 10.10.10.0. So let's go ahead and actually do that configuration, and we will see how that changes. So we're going to jump into router B and actually go ahead and do that configuration, and we'll see what changes, and we'll see how it looks after on router C. So if we go to B, we need to know what's the interface that's connecting us to C. This shows CP neighbors, so it's going to be fast Ethernet 1/1. So we'll do conf t, and we'll do fast Ethernet 1/1, and we'll do IP summary address EIGRP, our autonomous system number, which I think it's 100, and the actual summary that we want to send out. So it's going to be 10.10.0.0 and the mask 225.225.225.2.0. And it allows us to set a particular AD other than the one that's going to be used by default, which is going to be 5, which, as I said, again, now when we check the routing table, we're going to see a new summary for that particular network that has an AD of 5, and it's put there to avoid loops. And it's put there to avoid loops that can happen when we get traffic and we don't have a more particular subnet there, but for example, we have a default route. So, we're going to be sending traffic to, so the destination shouldn't be going, because in reality, we have an issue with our manual summarization where we maybe are grabbing more networks than we should. Imagine instead of doing that, we do 10.0.0.0.225.0.0.0. So we're saying, I have anything that's 10. And if that's not real and we have a default route there, we might be sending traffic along a path that really shouldn't be going to. And it also has an option of doing a leak map, which is if we need, for some particular reason, to not suppress some of them more specific routes. We have 100 more specific routes, but we want to, for any reason, send one of them or 2 or 3 or a group of them out, even though we are now also sending a summary. We can use a leak map, and we'll talk about that in another video. So another fun fact is that when we do this, we have the adjacencies that we have on that particular adjacencies we have a blip, basically, so they resync there. So let's do show IP route. We can see the summary that's pointing to null 0. So anything that gets to us for that particular, for that particular summary that we don't have a more specific route to, because remember, we are going to be routing to the more specific. That's what happens when we get traffic, when you get a packet, he looks in the routing table and he sends it out the more specific route. If we don't have that more specific route, that's there in place to avoid loops and to avoid that we are black holing traffic with sending it by a default, for example. Okay, so we see that we still have the two networks in B, and that's expected. Let's see what happens on C. You can see there that the resync peer braceful restart, the adjacency was resetted. And we can see here that we are going to have that summary route, and only that summary route. We no longer have the 10.10.1.0, and we no longer have the 10.10.2.0. What we do have is our new summary address, our new summary prefix, which from the perspective of routing C looks completely normal from any other EIGRP route learned, and we have the other route that it's not matched under that particular summary, the one that we decided to leave there, so you can see that we could do manual summarization with a finer detail there. And we should have connectivity. If we do ping.10.10.1.1, I think we have connectivity. So we have summarized that. And if you look at it in topology, it's going to follow the exact same rules in the sense of we're going to get an advertised distance from router B. Router C is going to add the cost that it has to reach router B. And exactly the same, just the way that we have in EIGRP to do manual summarization, which is what you will probably do more often in a real-world environment, because remember, we want to make sure that by summarizing, by simplifying the information that our neighbors and our devices get, we are not actually potentially causing issues. So it's something that you need to do quite carefully to avoid unforeseen consequences such as black holing traffic and causing issues or causing problems in your environment.